Let's go back to our scenario from class. A group of bank supervisors looked at the files of 48 applicants to determine who qualified for promotions. Of the 48 applicants, 24 were male and 24 were female. Out of the 48 applicants, 36 were chosen for promotions. Upon review, 21 of the chosen applicants were males and 15 were females. You are a lawyer who's been retained by the female applicants to press charges against the bank supervisors for discrimination. The women think that the high number of males hired is evidence of discrimination against women. Our original hypothesis is that there is no discrimination. Each person had an equal chance of being chosen. Our alternative hypothesis is that there was discrimination. Men had a better chance of being selected. So in this case, our population proportion is the probability of a man of being selected. So our evidence could lead us to two conclusions. Either we reject the null hypothesis, the outcome was so unusual that it probably was not due to chance, and therefore there was probably discrimination. Or we fail to reject the null hypothesis. The outcome was not unusual enough, so there's not enough evidence to say that there may be discrimination. What if we're wrong? There are two types of errors that we can make when conducting a hypothesis test. Type 1 is when our null hypothesis is true, but we incorrectly reject it. The way I remember it is that type 1 is the first hypothesis is true, but we reject. So in this case, there is no discrimination, our null hypothesis, but we rejected it and said that there was discrimination. This means the company will lose their lawsuit even though they shouldn't. Type 2 means that the null hypothesis is false, which means that the alternative is true, but we failed to reject the null hypothesis. So in type 2, the second hypothesis is true, but we failed to reject the null. So there is discrimination, but we failed to reject it and say that there is no discrimination. This means there's been an injustice against the female employees the company will not be paying for. In all hypothesis testing, there are two possibilities. The null hypothesis is true, the null hypothesis is false. We either reject the null hypothesis, or we fail to reject the null hypothesis. When H0 is true and we reject it, that's called a type 1 error. The probability of making this error is the same exact thing as the significance level, which is alpha. Our other alternative is that H0 is false, but we fail to reject it. This is a type 2 error. We call that beta. The probability of making a type 2 error is called beta. This is very difficult to calculate since we don't know the true value of H0. So the probability of correctly rejecting H0 is called a power of a test. So correctly identifying, or correctly rejecting, is called power, and the way we find that is 1 minus beta. So again, power of a hypothesis test is the probability of correctly rejecting the null hypothesis. The null hypothesis is false, and we will correctly reject it. Increasing power means that we are more likely to correctly reject the null hypothesis. That's what we want. We want to be accurate. We want to increase our power by increasing the sample size. The way we increase sample size, we know that we'll also decrease the standard error, or we can decrease type 2 error, which is beta. So let's look at an example. A police officer pulls over an individual that was drinking recklessly. The police officer is trying to determine if the individual should be arrested for driving under the influence of alcohol. Our null hypothesis is the individual is not drinking under the influence, or not driving under the influence. Our alternative is the individual is driving under the influence. We want to describe a type 1 error in context and what the possible consequences of making such an error would be. So remember, type 1 means that the first hypothesis is true, but we reject it. So in this case, we say that the individual is drinking when they really aren't. So our null is true, they are not drinking, but we say that it isn't true. Type 2 is that the second hypothesis is true, but we fail to reject. So we say that the individual is not driving under the influence, but they really are. Do you think a type 1 or type 2 error holds a stronger consequence? Well, in this case, a type 2 error because the person driving drunk will continue to do so and could hurt themselves or hurt someone else. Describing the power in context is the probability of correctly identifying someone who is driving under the influence of alcohol. The power is the probability of correctly rejecting the null hypothesis. So we're correctly identifying someone who is driving under the influence. Take a moment and try to do example 2. When you're done, come back and check your answer.